Cool. So the question I had for a while about quantum computers, and which you might be asking, is like, so what? Like, so yeah, it can store this vector, but computers can already um, uh, computers can already perform computations on matrices. We do it all the time for like AI, for instance, for
Mm.
neural networks. So like we already have this capability. So what's so special about this? Um, yeah, like why manipulate this particle to just get a vector representation? And well, something, yeah, I guess some confusion we should dispel is that this doesn't like fundamentally enhance the capabilities of computers. Like things that are undecidable or non-computable are still non-computable,
Mm.
but it can make things way more efficient. And the reason is, like, this isn't just a representation of the matrices. Like the physical state of a qubit,
Mm-hmm.
like actually stores all this information. Like the way a transistor's physical state stores its binary value, like a qubit actually like stores a matrix because of the state of the particle. This it's called the spin of the particle, I think, in physics terminology.
Okay.
Like the spin of the particle actually contains all of this matrix information, and then you can create a circuit that's not just like switches on these values. It's actually a set of matrix operations. Like you can do further transformations on this particle spin. And there's this other physical phenomenon called superposition
Uh-huh.
that allows qubits to actually hold many states at once. So this
Mm.
is why quantum computers can be applied for like parallelization, basically. Like yeah, they're able to, yeah, as I said, the storage increases exponentially, and they're able to parallelize like evaluations of many different inputs,
Mm.
which we'll get into. And this diagram I have on the right is um, sort of a demonstration of like, yeah, how superposition might work. Like,
What's the source?
so the source is like I think that's like a particle or like an electron emitting, or yeah, I think that's like a part, like a maybe like a metal emitting electrons.
Mm.
So electrons are like a fundamental particle, and yeah, I think this basically represents the double slit experiment. So if there's one slit, then there's like this one amplitude. So it's in a certain state, and then like the observation where you detect its passage through the slit, like basically collapses it into a single state. And the same over here.
Mm.
But like um, when they pass through two slits, like basically I guess I think you've heard is the particles are both waves and particles at the same time.
Mm-hmm.
Like they exist in this superposition of different states that's sort of wave like, and when they pass through, there's actually this interference pattern,
Mm.
and then when you detect it, it collapses into a completely different state. So it's not just like
Like complete different state, you mean from particle to wave?
um, like from yeah from basically from, I guess what I'm saying is it's not just a linear combination of these two. Like like you'd expect, like if this were classical physics, you'd expect when you see this, like if you have a light source, you see this pattern and you see this pattern when
Mm.
this is open, you'd expect just some like combination of these two, like two
I see.
hills, but
Okay.
instead you get this interference pattern when you observe it.
Oh, I see.
So like yeah, its state is like very complicated until you observe it, and it collapses into, yeah, a different like physical manifestation. And this is basically what quantum computing takes advantage of. Like it keeps it in this suspended state to perform the computation, and then when it evaluates the answer, it collapses it and gets this like interference pattern that it uses for to evaluate its results.
Hmm. How do you control the steps in the middle since we cannot observe it?
So I think, yeah, again, I'm not really well versed in like the actual physical requirements, but
Uh-huh.
like from what I've seen of the quantum chip, there's like a ton of wires that I think sends either like electromagnetic pulses or
Uh-huh.
some sort of like particle, um, like some sort of particle that they know will like interact with the spin. and like place it in these different states. And there are different ways you can interfere with the spin that are basically like different components of the circuit.
So we are messing around in the middle steps, although we cannot observe anything.
Yeah, as long as you don't perform an actual observation of the particle.
What does that mean? Perform a actual observation?
Uh, that's a good question. I guess.
Like, what's the difference between performing observation and messing around with it?
Yeah, this is what drove physicists and philosophers crazy. And I mean, yeah, we could do a whole different presentation on like the Copenhagen interpretation and all the controversy surrounding that, because yeah, it really bothered people that yeah, it doesn't really make sense that this could like be an actual physical change in the particle. And I, there's also this like very good video I'd recommend by 3 Blue 1 Brown, where they talk about the mathematics of the Doppler effect.
Okay.
You know the Doppler effect.
Yeah.
It's like the pitch of like a wave changes as a car passes.
Yeah.
They show how that's like the way we experience those sound waves is actually kind of comparable to this. Like the way like once it's like once like like whenever we observe the particle, we're only given like this like collapsed form. Like yeah, we don't really know if that's like if like something actually like fundamentally changes in the particle, and I kind of think that question doesn't even make sense at this level. But like we just know we're only the only the only patterns we observe are like this collapsed state. But we just know that it's not like a classical system where like the like the waves of these two different when these two different conditions are applied, like we don't just get like a linear combination of the two states. Like we get like it's a much more complex combination that's like we know mathematically must happen in like complex space.
Well,
But like we just get this one observation.
we can't even observe. Is that L2 and L1 and L2? Right?
Yeah.
So how do you know they are like these two waves?
Well, these were observed. So this so okay, yeah. So that's something to clarify. This is representing 3 different experiments.
Oh.
So like the same condition was set up where a particle was, I think like metal was like caused it to emit electrons, and then they had detected like basically the spectrum on this sensor. And when they had these two slits, they noticed like a pretty much like a parallel pattern.
Okay.
But when there were two slits in the same experiment, then they noticed like a totally different interference pattern.
Could you remind me what slit is?
A slit is just means like a tiny opening, like a microscopic opening, I think, to just to let like one electron through.
I see. And yeah, I guess I still don't understand how you observe this. Like,
Yeah, that's
is it like by my human eye and see that it's sort of like a black magic and suddenly changes, but if I don't see it, just using my hands.
Yeah, I think it's misleading to think of observe as an action. I think because I mean, yeah, because when they like, I think engineers like think about this, like think about it in this way, like you perform an observation, and then like that's one step in this like process you're setting up, but it's not like we don't know that like yeah, that action actually changes something about the particle. Um, Although we do, yeah, like we just know that like these particles are only like we only observe particles in these collapsed states.
Also,
But because of the way the system behaves, like we know that it must have like higher like representations and like higher dimensions.
so since we can't even see what's happening in the middle, how do we know that it changes at the end when we observe?
Just well, yeah, because Yeah, I mean we don't know fundamentally that it's changed. Like the wave function is, yeah, and it's still controversial whether the wave function is like describing something physically real or whether it's just a useful mathematical representation, which is what I sort of side with. We
Oh.
just know that like when we set up these different conditions, like we couldn't explain it classically. Like we
Mm.
couldn't explain it as, just particles that are like, in Newtonian physics that just like interact with each other,
Okay.
or as just waves that interfere in like a certain way.
Mm.
Well, like sometimes we observe it as a particle, like here, and sometimes we observe it as a wave, and
Hmm.
we just know that when we set up these conditions, we get like a certain interference pattern,
I
and
see.
like the only way to explain that I think is through these higher dimensions. Yeah,
Okay.
yeah. I wouldn't. I don't want to get too deep into like the philosophy behind this because I mean I don't really understand it myself.